record on. Okay.
Recording in progress.
All right, everybody. Welcome back. We're going to do 11.3 today, but before you do that, I thought I'd do a quick recap of things we've learned since the midterm. Kind of try to tie everything in together because there's a lot of connections. So mostly we've been doing confidence intervals and hypothesis tests. Stupid book. And we've done so far. We've done the samples samples we've done. We've done one proportion. That's my way of saying one proportion test. We've done one mu, which is a one mean sample group. We've done two proportions where we did two samples proportion, comparing proportions. And we've done 2 mu paired. So we've done the paired means test. Today we're adding 2 mu unpaired. And something that needs to happen for all of them, everything needs to follow a normal distribution. Normally distributed. Or meet certain criteria specific to each test. How does this compare to confidence intervals? For each hypothesis test, we have had an alpha, which is our level of significance. And what we're basically doing is we're getting cutoffs. Oh, that's not centered very well. Let's try this again. Let's see. I didn't go low enough. There we go. We'll put it there. So what we've been doing, if this is our level of confidence, like if it's 0.05, the area filled in on our confidence interval is 1 minus alpha times 100%. That's for the one-tailed test. I'm sorry, two-tailed test. Or we were doing 1 minus 2 alpha times 100 for one-tailed test, either left or right. And this is like the normal distribution graph. And we were trying to see if the p-value, well, it's really the test statistic. Test statistic slash p-value lands inside the confidence interval. If it does, we don't reject H naught. This is all behind the scenes, but we've shown we've loaded both up, and if it's no, it doesn't land inside, we reject H naught. So we want to know, does it land out here? Is P out here, or is P in here? That's kind of like the basics of what we've been doing. Leave that up for like 30 seconds, and then I'll go on to refresh your memory of confidence intervals and a hypothesis test, and we will jump into 11.3. All right, if you need that out longer, let me know. Again, this is all a recap, so you've seen all of this in one shape or form or another. Just kind of not all at once. When we're doing confidence intervals, we make a statement of confidence. We are blank percent confident that the true proportion or mean, true parameter is a better way of going with it. Parameter covers proportion, mean, standard deviation, lies between blank and blank. This is our level of confidence. And I'm going to call it X. X is that the 1 minus alpha or 1 minus 2 alpha times 100%. And when we did this, we would get a lower limit and an upper limit. That's a basic form of a confidence interval statement of confidence. If it's a proportion, we might list this as percentages. If it's a mean, we should probably list units. Something like that. And then we had hypothesis tests, which had 5 steps. Step 1 was to identify and label H naught and HA. The null and alternate hypotheses. we'd make a note of our level of significance. If it's not given, we would decide on one or use a default one. Default alpha is 0.05. Which represents one of the, up here would be 95% confidence on a two-tailed test. Then we got on the computer and we calculate our test statistic and p-value. And this was our StatCrunch. But maybe when you're doing it outside of here, if you work in a profession where you need to do hypothesis testing, R is a common statistical software platform used. There's another one with S's in it, like IPSS, or I forget what it's called. I have never used it. I've used R, but I haven't used the other one. There's a couple major statistical softwares out there. And after that, we had enough to go forward with our decisions. So at this point, we would compare the p-value to alpha. If p-value is less than alpha, the p-value is too low, reject the HO, support HA. And if the p-value is not too low, then we do not reject H0 and we do not support HA. And finally, our conclusion. This is a statement about supporting or not supporting HA. Based on the evidence. Give you a pause. As a reminder, H0 always had the equal sign in it. And HA had the not equal, greater than, or less than. Finally, let's look at the different types of setups we've done for H0 and HA. So maybe the category I'll list, H0, and HA, the symbol. So for the one proportion test, we did H naught was P equals blank. HA was P doesn't equal or less than or greater than the same value. Let's call that value smiley face. One mu was similar. The one means test. We just put, instead of P in, we put in mu for mean. That was chapter, what was it, chapter 10? These were chapter 10. Chapter 11 are the next two. We had the two proportion test. And H naught was P1 minus P2 equals 0. With HA being P1 minus P2 doesn't equal 0. And this was an editable value, but 0 is usually what we go with. The two mean tests paired. They used mu d, which represents mu1 minus mu2. And then mu d for HA, mu d does not equal 0. Or one of the other symbols, of course. That's everything we've done so far. These were chapter 11. Along with the last one that we're doing today, 2 mu independent. And on this one, I don't think they have mu d on this one. I think they just say mu1 minus mu2 equals 0. And HA is mu1 minus mu2 does not equal 0. That's our new stuff that we'll be doing shortly. Give you a second to process all that. Guys ready for some more? Oh, I see a chat bubble. I'll be putting it up pretty soon, Natalie. It's the final is on Canvas, not MATLAB, and it's 10 questions. I think I have a few more questions that I need to do for our annual review for statistics courses. We do it every 3 years, so it's not annual, I guess. Every 3 years, we give students questions. I might do that as a separate quiz, though. It won't. It needs to be done, but I think I'll make it extra credit to motivate people to do it. And it's not whether or not you get it right or wrong, it's whether you do it. The idea is to see what you've learned in your statistics classes. Hopefully you've learned something, but if you haven't, that will be soon enough though. All right, so what we've done so far in StatCrunch wise, we would do stats and then proportion stats or T-stats. Then we'd have either one sample, two sample, or for the mean only, for T only paired. So today we're doing stats, T-stats, two sample. 11.3 is on two sample mean test, not paired. So independent. And that will be stats, T-stats, two samples. This is a lot like the two proportion test. We are comparing the means from different groups. From two groups. Or samples. So, I've told you we've had requirements for everything. What are the requirements here? We need simple random sampling. That's like everything. And then we want both populations to be normally distributed. Or, that should say or, not on. Or N1 is greater than or equal to 30, and 2 is greater than or equal to 30. Our sample sizes are bigger than 30. And we want them to be less than 5% of the population. Just like we had with the one mean test. And these samples should be independent. We almost always want independent group samples. The only one that really has a dependency so far is the paired test. For the paired test, N1 had to equal N2, But generally for the independent test, N1 does not equal N2, but it is okay if it does. And what does StatCrunch need? We need the sample mean for both groups. We need the sample standard deviation for both groups. And we need the sample size for both groups. S does not have a bar over it. What am I doing? So our mean, our standard deviation, and size. It needs one for each. The one mean test had all of these, but just for one group. It had the mean, the standard deviation, the size. Let me know when you're ready for some more paint. Well, let me know if you're not ready, I should say. All right. There is one other option that's listed in the.
Can you go back to that lesson, please?
Yeah. Definitely.
I'm dead.
All right. Good stuff. There's one other option that's available in StatCrunch. When we do it, it'll ask you, do you want to pull variances? And what this is for is when this is when the standard deviation and variance should be the same for both groups. And normally there is no reason to assume this. So leave it unchecked. Let's see, my data. I want to use an example from something I've done, my own personal real life project. if I can find it. Ooh. Click that. Maybe I just better click it and come back to that later to do the other one. All right. So for our first example, Professor Jones believes that spending 1 week, or let me rephrase that, spending the first week of class focusing on soft skills and self-confidence can boost grades or enhance learning. Let's say that. Soft skills like study skills, time management, a growth mindset, faith in yourself, or believing in yourself. Those kind of types of things. So I implemented this in spring of 2019. He did this and compared results to fall of 2018 for an intermediate algebra class that we do not even offer anymore. With recent legislation, we had to stop offering it. You might be able to access this in my data. I think it's open. This was comparing grades Jones FA. Dataset and StatCrunch. Seen on the left. So what you see here are final grades. What happened after the entire course was done? If you're ready for more, we'll start doing the hypothesis test. We got another example we'll do from lecture notes, then we'll do a homework problem, and we'll be done. So, hypothesis test. He thinks that, or I think that, I don't need to talk about myself in the third person. The procedure's done, what he did to change it, improved grades. That's how he measured enhanced learning. And I've got two sets of information. I've got spring 19 and fall 2018. Now, if I think that this improved my grades for my students, which mean should be higher? Which group should have the higher mean? Fall 2018 was the old method. Spring 19 was the first time I did no math that first week of school. Which group should have the higher GPA? Or not GPA, but final grades? Anybody?
Spring 19.
Spring 19, yeah. If it worked, spring 19 should be higher. Or greater than. So H naught wants a mu1 minus mu2. And HA is going to be mu1 minus mu2. And we just have to decide what symbol we're going to use. We should label our groups. If I label them in order of when they happened, if I say 2018 is, let me use a different color here. If I say 2018 is group 1 and 2019 is group 2, then my scores up here would be group 2 is less, or group 1, which is 2018, should have a lower score than 2019, which would give me 1 minus mu1 minus mu2 is less than 0. I hate using less than 0, so I'm going to label them the other way. I'm going to say spring is group 1 and fall is group 2, so that 1 is greater than 2 and mu1 minus mu2 is greater than 0. That's just me, but as long as I label them what each group is and follow that, it won't be a problem. You will still get the same p-value. So I'm going to group this off as the option not chosen. I'll say nah. That way, if you're looking at it later in your notes, you're going, what the fuck did he do? That's what he did. I didn't give an alpha in that problem. I didn't give you any alpha. So with no alpha given, let's just use the default of 0.05. And if you're all ready, we're going to go stats, t-stats, t-sample, and I have data. I don't have the summary. So I said sample 1 was spring, and so I'm going to pick spring for that group. Sample 2 is fall. Thankfully, they turned the pool variance off. It used to be default to on. And I just need to make sure my HA symbol matches. I chose greater than with the setup I had. And we will click compute. And I'll just confirm it. Mean of spring 1 is group 1. Nailed it. Fall of 18 is group 2. Nailed it. And I got the right HA. So my test statistic, t-stat, is 2.013. And my p-value is 0.0237. And then, now remember, we want to compare this to alpha. So I'm going to put them next to each other. And if I look at the first 2 decimal places, 2 cents is less than 5 cents. So the p-val is too low. We will reject the HO and support HA. And this means we are supporting Jones's conclusion or theory that spending a week studying soft skills is beneficial to students. There's sufficient evidence to support Professor Jones's claim. That using the first week for soft skills and for soft skills and self-confidence can enhance learning among students. Both sample groups were larger than 30, so they met the requirement. I want to point out the sample difference too, because I was really proud of this. mu1 minus mu2, the sample difference was 10.7. So the average score was over 10% higher. That's a full letter grade. That's why we didn't do any math the first week. I had you watch those videos and do a little essay and look at doing time management. Students that take that seriously and do it, it's easier to force people to do it in class because I will watch the videos with you and do stuff in class when we're in person. But hopefully, if you did it online, it should help you improve your performance. I even presented on this at a conference. I was so pleased with myself, and everybody was excited at the conference that stopped by and saw my presentation. They were very pleased. I hope they all tried it. No one's ever emailed me back. I handed out a lot of business cards. No one ever emailed me back. All right, let's look at another one. For this, I'm going to go to our lecture notes. And I'm coming down to 11.3. And this is the one I'm going to do. No, not that one. Let's do the paper towels one. Paper towels one is better. Yeah, this is a fun one. Oh, Jesus Christ, what am I doing? Okay, so you guys ready for this one? This is from page 134 in the lecture notes. It's on Bounty, or it's on paper towels. So, as a group of COS students wanted to test the strength of Bounty paper towels as compared to Kirkland paper towels. So to make the comparison, they got each paper towel wet with the same amount of water. They measured it. They suspended the paper towel between two stacks of books so that it was rigid, and they stacked pennies on it until the paper towel broke. And the result of their experiments are given in the table below. And I'm going to enlarge this font also. We want to test the claim that Kirkland paper towels are stronger than Bounty paper towels. And they've given me alpha equals 0.01. So how do you think they were measuring strength by putting pennies on it? It's kind of like what you would think with normal strength. It's the more you could lift or hold up. So it was able to hold more weight. So Kirkland being stronger than Bounty should mean that there's it has more pennies. And if this is a measure of the number of pennies, Kirkland should have more pennies than Bounty. So Kirkland is greater than Bounty. All right, it doesn't say that they're normally distributed, but I think it's safe to assume that a major product brand line tries to keep things as normal as possible. So I think it's safe to assume that it's normally distributed. So we can do our two hypothesis test. And I'm going to copy the data over into StatCrunch. Oh. Yeah, Caprice, I was all sneaky about it, wasn't I? You didn't even know. I'm like a ninja. All right, so maybe I'll make a new data table. Actually, I think I might already have it. I do. I got the Bounty and Kirkland already saved. Awesome. I at one point got smart and started saving my data sets in StatCrunch that I use. So, our hypothesis test. If I call Kirkland group 1 and Bounty group 2, mu1 should be greater than mu2. And if I subtract mu2 over to the left side, I have mu1 minus mu2 is greater than 0. That is going to be HA. H0 should be that they're equal. We already have our alpha. And let's take a look at what we get in StatCrunch. So I'm going to do stats, t-stats, to sample. Again, I have data. I want Bounty to be greater group 1. That's what I said. Bounty was group 1. Nope, I said Kirkland was group 1. And I said Bounty was group 2. I'm over here reading it, and I said Kirkland's group or Bounty's group 1, and it's clearly not. All right. Kirkland group 1, Bounty group 2. And I got greater than 0. Check, check, check. So their results. T-stat was 8.02. P-value is less than 0.00030 zeros and a 1. And if I bring alpha down, for alpha, p-value is definitely less than alpha. If I compare the first two decimal places, 0, 0 is less than 0, 1. So I've got the p-vals too low. Reject the HO. Reject the null hypothesis. And support the alternate hypothesis. And the students thought that Kirkland paper towels were stronger than Bounty, and they had evidence to support this. So there is sufficient evidence to support the claim. That Kirkland paper towels are stronger than the Quicker Picker Upper. Isn't that the ad they used to do? Bounty, the Quicker Picker Upper? Look at that sample difference, 278. So that sample difference tells us how much larger mean 1 is over mean 2. Group 1's average was 278 pennies more. Now picture a roll of like pennies, like 50 cents. Now make it 5 rolls of pennies. That's a good amount of weight in your hand. 5 rolls of pennies. That's pretty hefty. They held up quite a bit more. Any questions on that one before we go to our last problem? All right. Here we are going to our homework set. So I realized there was a problem on Tuesday night with the math lab. I extended chapter 10. There were several students that put off doing the homework till Tuesday night at 9 o'clock. This is why you don't wait till the last minute to do homework. Not every teacher is merciful and just like the great Hefe. We're going to look at question number 18. Assuming I picked the right one. Should be on carpets. Yes. So chapter 11, problem 18. So if you want to follow along in your own homework set or just watch it, take notes, we'll go from there. A researcher wanted to determine if carpeted rooms contain more bacteria than uncarpeted rooms. So carpeted more than uncarpeted. The table shows the results for the number of bacteria per cubic foot for both types of rooms. Determine whether carpeted rooms have more bacteria than uncarpeted rooms at alpha equals 0.01. Normal probability plots indicate the data are approximately normal, and box plots indicate that there are no outliers. State the null and alternate hypothesis. All right. So it says let population 1 be carpeted rooms. So they have specified what they wanted. Carpeted is group 1 and uncarpeted is group 2. And more than means greater than. So mu1 should be greater than mu2. And if I move the mu2 to the left with subtraction, I have mu1 minus mu2 is greater than 0. That's going to be my HA. Which means my H naught is mu1 minus mu2 equals 0. Oh, they have it listed in this format, so that's the one I want to look for. I want mu1 to say greater than mu2, and it needs to be on H1. They use H1 rather than HA. That's definitely wrong. There's both. You need to have H naught as definitely an equal sign. So A is completely out, no equal sign. B, H naught has the equal sign, but it's got the wrong symbol. It need the greater than one. C and D also have H naught the same. C's got the wrong symbol. D is the correct symbol. mu1 and mu1 greater than mu2. Determine the p-value. I need to use the data set. So I will open that in StatCrunch. Stats, t-stats, 2 samples with data. I want group 1 to be carpeted and group 2 to be uncarpeted. And I want the greater than symbol. So my t-stat is 0.745. My p-value is 0.2348. And I want to compare that with 0.01, which is alpha. And this is something that annoys me about the authors of this book. They know they're using StatCrunch. They know StatCrunch does mu1 minus mu2 is greater than 0. What does it say in the problem? It doesn't do that. It doesn't do mu1 minus mu2. I think that's kind of rude. The p-value to 3 decimal places. 235. Okay, so now that we want to know, do we want our conclusion? So we're going to compare decimals. 0.23 is larger than 0.01. So the p-value is not too low. So we do not reject H naught. We do not support HA. Which means there is not enough evidence to support the claim that carpeted rooms have more bacteria than uncarpeted rooms. So let's find the one that says that. We want to not reject H naught. Is there only 2 options? No, there's few. So I want do not reject not H not. That's A or C. A says not enough evidence, where C says there is enough evidence. We want to go with not enough evidence. And that'll be it. So that's it for today's lecture. Natalie, your question earlier about final exam practice and stuff like that. I'm going to give you 10 problems. 2 of them will be confidence intervals. 8 of them will be hypothesis tests. You've already learned 5 of the hypothesis tests. You will see problems like this. There will be 1 problem for each types of hypothesis test. I will give you the word problem. I will give you the results from StatCrunch, so you do not need to use MyMathLab. You will get the results. Your job will be to go through this hypothesis test. So it's important you know this process right here. And if you've noticed, it's kind of all the same. The only thing that changes is H naught and HA. Everything else is the same for each test. So, but the problems aren't labeled like 2 sample test, 2 sample paired. So you have to be able to go through the problem and decide by reading the problem what kind of scenario it is. Is it a 2 proportion test? Is it a 1 mean test? And that's the practice exam. We'll go over stuff like that. We'll even do a review in this session, like an evening session. Other than that, that's it. Are there any questions? All right, I will bid you adieu. Have a good evening.